All right, good morning, everybody. My name is Sandip Parikh. I run our retail solutions architecture practice for Google Cloud. And this morning, I want to talk to you about end-to-end collaborative data workflows and what those look like inside a Google Cloud platform. So what we're going to cover today, first I want to lay out a pretty simple, straightforward challenge for you. And then we'll break it down into the individual tasks that we're going to have this team sort of work on and try to work through. And then we'll map those tasks to a set of steps, components, and tools that you would want to leverage inside of GCP to actually accomplish the initial challenge. And then we'll try to put it all together and give you a sense of what that, again, that end-to-end workflow looks like. And I'm hoping I'm going to be able to show you a little bit of a demo as well. Now, unfortunately, it's not going to be a live demo. It turns out it takes about 6 to 8 hours for the end-to-end workflow, and I didn't want to keep you here for the whole day. So we're just going to, I'll have to do it Food Network style, and I'll have everything kind of pre-baked already. But we'll walk through what the steps and the UI looks like at every stage. And then finally, I want to close on what's next. And I'm going to try to leave a few minutes for questions at the end, and worst case scenario, just come find me right outside the hall, and I'm happy to chat it up with you. We've also got mics in the aisles here as well. All right. So with that, what problem are we trying to solve? What does a data team typically have to try to solve on a regular basis? So we'll pick everybody's favorite and say, our challenge here is to build a recommendation system. Now, that recommendation system is something we hope to use inside of a running web application. So you could imagine sort of a Netflix-style challenge here, where we've got a web app, we've got folks who are able to rate movies, and what we want them to do is be able to see recommendations in line as they're browsing. So what is a team made up of? What is the typical audience? What are the folks that are trying to put this thing together? So we've got sort of the typical cast of characters. Data scientist, a data engineer, a business analyst, and an app developer, right? And I think depending on your organization, those roles may be different. They may be, there may be some overlap among them, but ultimately, these are kind of the four main team pillars we typically see in a lot of customers. All right, so what are the sort of steps or the tasks that these teams have to work through? So the first thing is often fall to the data engineer. And that's where they've got to transform the data they're given, right? You could imagine a DBA or someone that's kind of running SRE for a database infrastructure. They may just export some of the source data that they're going to use to build this recommendation system. So the first step is taking that export, taking that raw data, and turning it into something useful. The next step falls to the business analyst, where they actually have to develop some kind of an understanding of the data, right? This may be things like, just early analytical queries, something that gives them a sense of what does this data really look like, right? We're not going to have the data engineer figure that out. It's really on them to transform. Then it falls into the business analyst to understand what's inside that data set. Well, then we're going to get to model building. So the first step for the data scientist now is to prototype an approach. And you can imagine at every step of the process, these folks are learning from the previous steps. So that data scientist may collaborate with that business analyst and get some early indication of some of the patterns that are inside that data set. And they may use that as they're prototyping their approach to building this model. But first, they've got to get that prototyping done. So they've got to come up with some kind of an approach they're going to use to build this machine learning model. And then they actually have to physically build it, right? They've got to build it, train it even on a small data set or a local environment, but they've got to do something to actually create this model. But then once that model is trained and ready to go, how do they get it out into production? And that's where the data engineer comes back into play, right? Because it's not only important just to build the model, know that it works, we've also got to run this thing at scale so it can support the application downstream. So that data engineer is going to deploy that model to production. And then the last step is going to be integrating that prediction mechanism with the applications. All right, so let's start with the first set of tasks. How do we transform and understand data inside of GCP? Right, so remember, that's that first chunk of that timeline with the data engineer and the business analyst. So there's three main steps that typically fall into this bucket. And I'm sure this is not completely exhaustive, right? There's typically a lot more work that might go on here, but these are three of the biggest pillars that we often run into. So the first step is really going to be acquiring that data, right? Grabbing all that raw data and storing it in some kind of object storage mechanism. something that's nice and scalable, we can access from a number of different tools. Then we'll have to turn all those flat files into something useful, right? Put some structure around that data, cleanse it, transform it, turn it into something where we can actually run queries against it and start learning from the data set. And after that transformation is done, we actually want to put it somewhere where we can access it, right? So typically inside of a large-scale data warehouse. So this is day 3 of Next, so you probably can guess which tools I'm going to show you here. But so for acquiring and storing the data in object storage, GCS, Google Cloud Storage, is a great fit for that. For transforming the flat files into structured data, we actually have a bunch of different tools we can use here, but I like using Dataprep, mostly because it's a nice visual way to sort of dig around and understand sample data, and we'll talk through a little bit of that as we get further in. And then the last piece is BigQuery, right? Petabyte scale analytical data warehouse, a perfect place for ad hoc queries. Again, we're in kind of understanding and model building phase, so it's early on. This doesn't have to serve any kind of transactional traffic or anything. All we're focused on doing is giving ourselves access to query and understand the data. So if we dig into each one of those just a little bit, this is an example of what GCS looks like, right? It's just a nice bucket folder style approach where I've created a bucket in this case, and the data set I'm using as we're working through this example is like the Movie Lens data set. So I grabbed the 20 million rating Movie Lens data set, unzipped it, dropped all the CSVs into Google Cloud Storage. So now I've got the raw data sitting here. So the next step is transformation. That's where Dataprep comes in. Now, as I mentioned, Dataprep is a great data wrangling tool, right? It lets you pull in from Cloud Storage or BigQuery, transform all the data you want to transform against, and then actually dump that data back out into Cloud Storage or into BigQuery. So it gives you that input and output option. What's really cool about Dataprep is that behind the scenes, the transformations that you define, the steps that you take, the filters you run, are actually packaged up into an Apache Beam job. And that Beam job is actually pushed to the data flow service. So the actual execution mechanism here is actually Cloud Data Flow behind the scenes. And now the inputs and outputs here with Dataprep are somewhat limited, right? This doesn't cover the breadth of the platform. If you need a level deeper of maybe transformations, or maybe you want to get through maybe inputting from Cloud Data Store and outputting to Cloud SQL or Cloud Spanner, that's where you want to incorporate data flow. But for our use case, Dataprep works perfectly well because our data is living in cloud storage, and we want to make sure it lands in BigQuery eventually. So this is an example of the Dataprep UI, and what you'll see, and again, I'll go through this a little bit more in depth as we get to the demo part, but what I want you to notice is that we've got this kind of row and column setup, right? This is a CSV that I imported, and this is the cleansed kind of ready-to-go output. But what you'll see across the top there in those green bars are actually Dataprep sampling the entire column and showing me a distribution of all possible values there. And so that kind of tooling makes the analysis process much easier, right? It helps me figure out which of these data sets do I want to worry about, which of these columns do I care about, which ones do I want to potentially transform or join as I'm thinking about what I'm going to give access to my business analyst. And so here's what a flow looks like. So in the example that I'm going to show you, I have the Movie Lens 20 million rating data set. So I've got the movies data set up at the upper left. The next one is ratings. The links file includes like the movie database link or ID and the IMDb ID for the movie. And then the last one in the very bottom there is the tags. And I didn't really worry too much about tags. But what you'll see up here is that I've taken the Movie Lens, or the movies portion of the data set, and the first thing I did was clean it up a little bit. And so things like genres were pipe-separated text fields, and I wanted to make that a JSON array. So I was able to do that inside there, as well as do things like extract the year out of the title and make that its own column. Then I was actually able to join it with other data sets inside of this whole large group. So I took the ratings, and I actually created an average rating, right? So kind of a little bit of a swoop down to the bottom there. But I was able to compute the average ratings per movie from that 20 million set, and then push those average ratings and join them up back with the movies. And so the nice thing here is that the movies data set itself was actually able to be enriched, all done inside of this tool. And so all of those little, and they're a little bit hard to see, but all those little arrows that are pointing to the right at the end of every step, those are actually the job. That's the output component. So that's where I get to decide, where do I want to put this data out to? Do I want to append it to an existing table inside of BigQuery or replace the data set? So you have a lot of flexibility with data prep. It gives you a lot of transformational power around individual data sets and how you might want to work with them, join them, use them. So once that set of jobs runs, all my data lands inside of BigQuery. And here's just a quick screenshot of what that looks like inside of BigQuery. So I've got my sort of options on the upper left, and I've got my data sets on the lower left there. And then we see a little bit of information about the actual physical data set itself. The screenshot's not very exciting. I'll show you more when we actually run some queries. But here's a quick or quick screenshot of what that looks like inside the BigQuery UI, so you can see. We can run standard SQL queries against this data now. So any SQL capabilities you might have for your business analyst, they're able to go ahead and run ad hoc queries immediately against this data set. So we're already making a little bit of progress through the work that we've got to do to get to build that recommendation system. So if we want to get a level deeper on exploring and understanding data, I think SQL is a really powerful tool, but it's not the right tool for every single person out there. And there are an incredibly huge number of business intelligence tools out there that we want to be able to plug into. So the great thing about BigQuery is that it does support things like Tableau and Looker and our own Data Studio product, so that you can build things like reports, dashboards, build kind of exploratory analyses of the data that you're looking at. So it's another nice way to think about how can I examine and understand this data? Because that's really what we're trying to get to. We're trying to make sure we can develop a really intense, in-depth understanding if we're trying to build a predictive component on top of it. All right, so we've finished the first major set of tasks, right? We acquired the data set, and we've transformed it into something useful. And we've got a bunch of tools we can use to really develop an understanding. But how do we make the next leap? How do we move into building a machine learning model? So that's where the data scientist comes in, right? If you remember, we have two big tasks here. One, we've got to prototype the approach. And the second is we actually have to build the model itself. So the components that you'll need to accomplish those tasks, right, for a data scientist, one, obviously you're going to need a pretty powerful machine learning framework, right, something that you can lean on heavily to support this kind of work. And then you actually need an environment to physically, prototype the approach within. So inside of GCP, we have two good options there for you. TensorFlow, which is a scalable machine learning library and framework, and Cloud Datalab, which you can just imagine as Jupyter notebooks or IPython notebooks as a service. So let's dig in a little bit. TensorFlow is incredibly powerful. It's also relatively complicated, and I'm a TensorFlow newbie myself, so this took me a little bit of work to get all this up and running. But think of it as a powerful open source library for really high performance numerical computation. The great thing about TensorFlow is I think it establishes a really nice kind of baseline, and what you're seeing within the ecosystem now is a lot of stuff that's sitting on top of TensorFlow, higher level abstractions that are making it easier and easier to work with, and TensorFlow itself is improving at an incredible pace. It actually is able to run on a number of different environments, though, as well, right? It can run on just bare CPUs, GPUs, or even our own TensorFlow or tensor processing units, or TPUs, that are available inside of GCP. And it can be deployed; those models can be deployed to run on anything from mobile devices to large-scale, VM infrastructure. So it really is a very capable framework. And there is a incredible number of blog posts, how-tos, guides, tutorials out there, right, all the way from formal to informal, of how to use TensorFlow for different classes of problem. So we've got a good framework we can build on. Well, now we need an environment to prototype it in. And that's where, again, Cloud Datalab comes in. And think of Datalab as just a wide-open notebook interface. But we've actually tweaked the Jupyter and the IPython components a little bit to give you access to some really simple tools. So, for example, inside that notebook, we give you quick access to running things like BigQuery queries or looking at files out of Google Cloud Storage without having to import individual libraries and set those up. So we try to make it as easy as possible and a first-class citizen amongst all the other data services that you might want to leverage. But inside those notebooks, you can explore that data. You can obviously analyze it. Visualization components are built right in. And it's actually perfectly suited to building machine learning models. And it actually plugs directly into using TensorFlow and even deploying those models later on. So here's an example of what the the Cloud Datalab UI looks like. Again, very notebook-driven, but you can see we've got a mix of, I'm running some queries, I'm charting some of the output, I'm importing some Python libraries, and I'm actually writing a function here for training. All right, so now we've got the first 4 bits done, right? We acquired the data, we transformed it into something useful, we were able to prototype our approach, right, with a machine learning framework and an environment, and we were able to start building our model. Now that that's all done, how do we, and maybe we even trained it in that case in a small kind of constrained environment. But now, how do we train it and deploy it and run it at scale and really incorporate the usage of that model? Right, so we've got, the next step here is deploying that model, training it and deploying it and running it at scale. So for the data engineer, there's 2 main steps they've got to take. First thing is they've got to push that model to the cloud to train it and then deploy it ultimately on a running service that can scale. And then they've got to integrate that prediction mechanism into an application. So the steps that we have there are, or the tools that we want to use there are Cloud Machine Learning Engine and our Cloud APIs, which are basically just the kind of endpoint you're going to use here. Cloud Machine Learning Engine is an incredibly compelling product because it takes your TensorFlow model, or it takes your training task, and it lets you run it on a much larger set of infrastructure. So you can run things like your TensorFlow models at an incredible scale without having to worry about spinning up those machines, configuring them, installing all the required software, coordinating the work that they do. Right? TensorFlow is built to be distributed. So we can take advantage of that and create a large cluster and deploy the job to so that it can complete the training process. And then when that training process is done, you can actually take that completed model and push it back up to the service and say, now I want to make this a serving model, and it gives you back a URL endpoint that you can integrate inside of your applications. So an example of what that flow looks like for pushing to cloud and training and deploying would be, you might want to do some light pre-processing or heavy, depending on your input data, but you're going to pre-process the data set you've got, and then you're going to submit a training job. And that training job is a Python TensorFlow training task. You're going to push that job up, and there are a series of parameters that we'll talk through quickly later on. But effectively, you're just giving this job to the service and saying, here's my training task. I want you to run it across a number of machines. Once that job is done, it'll actually have a little output model, and you're going to take that model and say, now create an entry for that serving model inside of CMLE, inside of Cloud ML Engine. And then you can create a version. So you actually have the ability here now to take different models you've created, attach versions to them, and maybe even A/B test them as far as like predictions go. So you have that capability here. Once you run that last command, it's actually going to create that URL endpoint and give you an option to, again, integrate that into an application. So there's 2 ways you can actually test the prediction mechanism. Coming through the top, we actually have a test capability built into the gcloud command inside of the gcloud SDK. So you can just run gcloud mlengine predict, tell it the model you want to predict against, give it some input data, and out pops your answer. Or you can come in from the bottom and integrate into application. And it really is just a URL you get to post against. Right? This is a service that we host for you and scale for you as needed. So it's just an API you integrate and you can post against. Or you actually have the option of going a step further here and saying, I'm going to wrap this inside of a more powerful like cloud endpoints approach, so I have a good set of API management capabilities on top of it. It's up to you. But ultimately, it's still the same back-end infrastructure where both those commands land you inside of Cloud ML Engine, and you get those predictions back out. All right, so let's put it all together and figure out what this looks like. So you remember, we've got these 6 main kind of components, right? Transforming, understanding, prototyping the approach, building the model, deploying it at scale, and integrating with applications. So when you map that back to GCP, right, you get the sort of appropriate kind of components here, right? So for transforming, we use Dataprep. For understanding, we would use BigQuery. For prototyping and maybe building the model, we might use Cloud Datalab. When we deploy it, we're going to deploy it to Cloud ML Engine. And finally, we'll use the API that comes out, or we can, again, use Cloud Endpoints to actually integrate with our running application. All right, so as part of this, I did want to walk you through as much of the UI in real world as much as possible. So I'm going to show, don't tell, and here's where the demo should be. So if we could switch to the Chromebook. All right, great. Can you guys read this? Yes? OK. I'm going to try and make it a little bit bigger. All right. So there's not too much exciting to show here other than this is the cloud storage bucket where I actually dumped the Movie Lens 20 million rating data set into. So you can see these are just the raw CSV files. So not terribly exciting on this part of it quite yet. But now we can actually start a data prep flow. So what I did inside of data prep is I started a new flow, and I imported those data sets. I said, here's where my data lives inside of Google Cloud Storage. And now I actually want to take some action on it. So the first one was the movies data set, if you remember. And we executed this cleanup phase. So I'm going to switch to my cleanup tab. I'm going to show you. So inside of data prep, as I mentioned earlier, you can see across the top that it's actually sampling all of these columns and showing me the distribution of data in them, which is actually pretty handy, again, as you're trying to figure out what is in these data sets. And so what you're seeing right now on screen is actually the completed version, right? This is the cleansed version. Well, what if I want to see the initial version, right, before I actually ran all these steps that are here on the right? So I can click on a step, and I'll show, now it's actually showing me the kind of output before that step. I'm sorry, the version right after it executed that step. So you'll see I've got things like the movie ID, the title with the year still in the title, and the genres as a pipe-separated column. But that pipe separation is not really helpful. So I'm actually able to, here, define a set of steps like extract occurrences of the word from each of those pipe-separated genres, and then drop that into a column here on the right called extract list genres. And you can see it's an array. And then I actually am able to delete the field and rename it to genres, right, to match up what we need. And then the last step is I want to extract the year from that title and actually make it a separate column on its own. All right, so we can see the steps here. And I'm just using regular expressions to pull the year out, drop the parentheses, and move that into its own column. And if I show you this step in a little bit more depth. So the first thing I do is I pick a column. And then I have the option to pick either some canned values here for searching inside that column, or I can pick a custom pattern. So I picked a custom pattern and it said 4 digits. Made sure I gave it some parameters about when to start and end that regular expression. And that's it, and it's off and running. So I was able to add that to the flow. Then I changed the title, that extracted column, into an actual year. And then I did a little bit of cleanup on the actual individual column, movie titles themselves. So things like removing quotes, removing any extra spaces that were trailing or at the end. And that's the cleanup step. So if you go back to the flow here, so the first thing I did was I took that raw CSV, I imported it, I cleaned up the file a little bit to make it a little bit easier to query and use later on. But I'm not done yet. I want to add a couple of fields in. So I wanted to add things like the links, the movie database ID itself, as well as the IMDb ID. And I also wanted to have inside that movie's data set the average rating and the number of ratings. So on the ratings data set, I actually added this average ratings by movie, and you can actually see the functions that it ran. I just basically collapsed that rating data set. And the way it's actually originally organized, it's user ID, movie ID, rating, and a timestamp. So all I did was I grouped by user and movie, and I collapsed it down into compute the averages themselves. And then I was able to join that back with the movies data set itself. So here's what that join looks like. And it's a pretty simple approach. First thing I did was I executed a lookup, if you can see that up there, against another data set, in this case links. So I was able to pull in the links file. And then I did another join where I look up the movie ID against the movie ID in the ratings data set that I computed, and actually pulled in the average ratings that I wanted to. So now my data set looks like movie ID, average rating, number of ratings. I did total rating as well. And then the links, as well as the titles, the year, and the genres that we talked about earlier. So I've got a pretty far way through transforming that data set. So now the last bit we have to do is, as I mentioned, is this little arrow up here. And this actually is the job, right? This is where I'm telling the flow, where do I want to deposit the result of that transformation? And so in this case, I'm going to pull in from that CSV, and I'm going to replace whatever's in the movie lens data set inside of BigQuery. So when I run that job, what happens, and I'm not going to run it now, unfortunately, because it will take about 30 minutes, but what's actually happening behind the scenes is it's taking those transformations, all that work you saw, the components in that recipe, all those tasks, and it's packaging them up as an Apache Beam job, and then pushing that Beam job to the Dataflow service. And so the Dataflow service gets that job and says, okay, well, I might need to run 4, 5, 6, who knows how many workers. I'm going to spin up those workers. They'll pull in the input data set and actually execute those transformations. Right? So this is something I don't have to get involved in. I just run that job, and I get to walk away. And then if I want to see the results there later on, I could see that I ran some of these. Each of those was a job outcoming. So this movie lens component, right, it ran for looks like it took about 12 minutes to run it through. The ratings data set took a little bit longer because it's a much larger file there. But we've got the data in BigQuery now. So now it's in BigQuery. Why don't we go ahead and take a look at it and do some queries and see what it looks like. That might be a little bit too big, so I'm going to just close this on the left. Inside the BigQuery UI, inside of the Cloud console, you can see things like query history, any saved queries, job history. If you want to start some transfers from another service, you can do those. But we're going to right now focus on just querying this data set that I've got. So the movie lens data set, and I'm looking at the movies table itself. I'm just going to close that. And so we can see here, inside the UI, I'm able to take a look at things like the actual fields that are in this table, some details around maybe the size, right? It's not incredibly large, it's about 2.6 megabytes. And we can also do a quick preview. So we actually can go through this and again, start exploring the data and looking at it in a little bit more depth here. But looking at it just by itself is not very exciting, so why don't we write a query? So maybe I wanted to find out, let's say, what the top rated movies are for the action genre. So what I would do is select, say, movie ID, average rating, and title, and the genres. So I want those columns to show up, and I'm going to do from movie lens.movies. And I would need to filter now by a specific genre that I'm looking for. So I'm actually going to be able to examine inside each of those rows the array field that holds all those genres and actually pull out the one I want. So I'm going to search for the comedy genre. So I'm going to use the string position function, say where inside of the genres field, I'm looking for, let's say, action movies. And action's greater than 0. That means it found the column there, or found that entry inside of the genre. And let's say the top 10. Well, actually, let's first sort it. So we can say order by number of ratings, and in descending order, and by average rating in descending order. And we're going to get the top 10. Oops. Got a little typo. Never type live on stage, because you will always mistype. All right, so that's our query. And one quick thing which I love about the BigQuery UI is it's hard to read through this later on, so you actually have this nice option of formatting your query automatically, so it makes it a lot easier to read later on. Definitely take advantage of that if you can. But now we can run this, and it's actually going to run in a couple of seconds here. All right. So now we've got a list of the top 10 action movies, and you can see the genres in there on the right side. We've got the list of movies here. None of these are probably surprising to any one of you, but again, this is a sample data set, but you get the sense here. Right? We can actually start querying and playing with this data, and we can even do things like right from this UI, click Explore in Data Studio, and it'll actually throw us in there and start giving us some canned charts we can work against. But now we've gone through the first steps, right? We've started, we transformed the data, we developed a kind of a quick understanding around it using SQL, or you could use other tools like Data Studio, Looker, or Tableau, or pick your favorite BI tool. But now we want to move on to the next step. We want to say, well, let's actually do some analysis from the data scientist perspective. So here's my Cloud Datalab Python notebook. And as I mentioned earlier, inside of those notebooks, you actually have this great capability to run a whole series of kind of canned commands around things like running queries right in line without actually having to do the work of importing the BigQuery SDK and connecting to a data set and running a query that way. We actually give you a lot of those capabilities just sort of out of the box to make it easier over time. So here I can actually show you, let's just do a quick little SQL test of, I can run a query using the %SQL directive, and I'm going to just select the top movies, the top 10 movies that I find back from the Movie Lens data set. I can execute that query, and you'll see that, yes, you'll note that that was cached because I ran all this stuff about 30 minutes before you guys got here to make sure it still worked. So now we can see all the outputs here. And actually, one of the other things we do, we give you a couple different ways to query. So one is that SQL directive. Another one is the BQ directive. And the BQ one is actually a lot more powerful. It gives you different capabilities inside of the command. So if I were to write something like, let's see, let me just add a quick little code bit here. I can say %BQ help. And you can see there's a whole bunch of stuff you can do here, right? You can take operations on data sets, tables, create or execute queries, right? Do things like sampling. You could even create user-defined functions, JavaScript, and run those. So you have a lot of work you can actually create inside of, or a lot of work you can do inside of this notebook all by itself. But what we're going to do here is we're just going to say, let's do a quick aggregation, a quick group by of all the movies in our data set by their average rating, right? Just to see what that distribution looks like. So the first thing I'm going to do is I'm actually going to write this query out. So select average rating as rating, count star as count from movies, and group by average rating. And now I can actually run that. And it actually didn't run the query. All it did was it saved it into that variable name, average ratings count. And now I can actually refer back to that later on and say, just execute that previously named query. So I'll run through that here and show you. So that's going to actually run that average ratings count query I created. And it shows you the distribution, which is good, right? Now we can get a quick view of it. But what if that's not the best way to look at this data set? What if it's easier to create a chart? There's actually, it turns out, there's a chart directive as well. And I'll show you a quick bit of that help. So I can say chart help. And inside there, you can see we actually support a number of charts depending on the kind of data you want to look at, whether you want it to be a candlestick chart or maybe a timeline or a tree map or a histogram. All those capabilities are kind of baked right into the console here or inside of this notebook. So I'm going to pick columns because it's an easy way to visualize that data set. So all I have to do here, again, is refer back to that query name that I used earlier that I executed against and just tell it which fields I want to pull out from the resulting data set and see that column or in a column view. And now we can actually see the distribution. So this might help us as we're trying to figure out how we want to build our training task. It doesn't really tie into the recommendation approach, but I wanted to showcase a little bit of the power of Datalab because it does have a lot of capability baked into this one kind of straightforward UI. And then, of course, it is IPython or Jupyter Notebook, so we have the typical Python capabilities here. TensorFlow is actually already included, as are things like NumPy, sklearn. So I can say import NumPy, import scikit-learn. Oops. Or I can say import pandas. So we do as much as we can. Whoops. That's my fault. We'll come back to that one. We do as much as we can to make sure that there's a lot of the typical libraries that you want to use baked into the Datalab kind of core image that's running here. But you also have the ability to import your own, or to add your own. I'll come back to that one. So let's say I wanted to add something else, right? Something that wasn't in the image by default. So there we can actually run pip commands in line, and so I could pip install. Somebody yell out a library I should install here. I missed it. Say it again. I couldn't hear you. Sorry. So I'll just pick something. I'm gonna just pick the 6 library here because that's pretty straightforward. Actually, it might already be in there. No. All right. I picked something that was already there, but you can see running pip commands is also available to you. So if you need to install additional libraries that are not part of that core image, you can do that as well. And then the last bit is actually writing some Python. So I'm not going to run this here because there's a whole bunch more functions that I left out. But the goal here is, right, you could actually create your training task function right in line here and actually use some of those similar directives to run G-Cloud commands to actually push the training task function up to the ML Engine service to actually run it. And so I previously did some of that work. And let me take a quick look and show you what that looks like. So here's an example of what it looked like for me to submit the training job that I had earlier. Right, so up at the top, I've just defined a handful of environment variables, right, where the input data is, where I wanted to dump some of the output. In this case, this data was pre-processed. And I'm using actually a sample that I'll tell you about in a minute. But this sample actually takes the 20 million rating movie lens data set, and it trains a couple of different models. Right? It does one for a deep learning model and another for a matrix factorization model. And when you look down here at this command, what you're actually seeing is there's two different sets of arguments. The first set, right, the first set of arguments are the actual ones I need to pass to the ML Engine service. So things like, what is the actual Python module name of the task, right? In this case, it's trainer.task. Where is the path to that package? It's right in line in this same directory I'm in. Where do I want to stage the kind of intermediate output? Which region do I want to run it in? And what are some of the configuration parameters that I want to have there? Right, so we can specify all those. And then the second set of arguments are actually arguments to my trainer file itself, to my Python task. So here I'm giving it things like, where should I be putting some of the output data? What about the evaluation type, or maybe some of the other features that I'm trying to expose here? And then I'm also doing the exact same thing for the factorization model further down the way. And this is submitting it in an async fashion. So you have that option with ML Engine. You can either submit in synchronous or asynchronous. If you do it with sync, it streams the logs from your training output right back to your console. Or if you do it async, it gives you back a job ID and says, go ahead and check this job ID later on to see how it progressed. Now, if we take a look at the configuration, just to show you really quickly, first thing I'm going to do is show you. So this is one of the input configuration files we used. And this configuration bit is actually, these are arguments you could specify on the command line if you wanted to or not. But what they're basically telling ML Engine is, how do you want me to run your job? Right? So in this case, the scale tier I picked, and there are different ones, but effectively here you have the option of saying, I need something at the most basic level, so maybe a set of CPUs. Maybe I want to run on the quote-unquote premium level, which is, I think, one master and about 10 workers with GPUs, or I can run with TPUs as well. So you have a lot of flexibility to define how much you want done here, how many components you want to incorporate into your training set. And actually, one thing I didn't mention that I will mention here is at the bottom there you see a section called parameters, or params. And ML Engine offers this really cool notion of hypertuning your parameters. And what that means is you get to tell us some bounds on certain parameters. In this case, I'm going to talk about learning rate. There's a min and a max. And what I want ML Engine to do is run multiple permutations of this and tell me what's the right value for learning rate. So when it finishes this training, one of the outputs here is not just the model, but it's actually going to tell me the optimum value I should use for learning rate. So there's a lot of power just baked into this mechanism where you give it a task, you tell it which parameters are flexible, and that you want to get the most optimal outcome for those parameters. All right. So we could have submitted that training job, and when we submit it, it goes into, oh, that's a little too big. It goes into the ML Engine UI here, and I was doing a bunch of training and breaking things all over the place. So here's one example of the matrix factorization job I ran. It took about 2 hours because I was only running it on a single master with a couple of workers. Then you can see all the inputs that it gave you and the training output based on the hyperparameters you gave it. So now it's showing me for every single run, every single trial, what the learning rate it used there and what the kind of optimal outcome might have been. And if you actually were to look at this in line when it's running, you would actually see a breakdown of every worker and the CPU usage across all of them, the RAM usage. So you get a sense of what's actually physically happening behind the scenes when we're running those jobs themselves. But once that training is completed, right, we actually have to deploy the model to production. So that's where I'll show you the final step here. Oops. Oh. That's actually in the previous file that we were showing you, but it's the component where I can actually just run, again, a series of G-Cloud commands to actually deploy that model to a production kind of scaling service. And when you actually run those, a couple of those commands, you get a models in the model section here of the UI. So in my matrix factorization model, I created a default version, which is V1, and I now have the ability to use that model or set it as default or pick different versions here. Again, if you're thinking about maybe you have multiple models you want to serve for a given use case, maybe for purposes of A/B testing, different recommendation approaches, the version capability is really nice to have there because you can pick and choose what you want to deploy into. But now that's all done, right? We've trained our model. We've got it ready to serve. We've pushed it up to production. So the last step in this process is actually getting a prediction out. So what I'm going to do here is show you what that prediction looks like really quickly on the command line. So I'm going to do gcloud ML engine. I'm going to predict. I'm going to pick the model I want. So in this case, I'm going to choose the matrix factorization model. And then for my input, you have the option of supplying either a set of inputs inside of JSON and doing a synchronous prediction, or you can actually do a bunch of batch predictions. In this case, I'm going to do a quick synchronous one. And because this data was pre-processed using TensorFlow records, I'm going to use a canned TF record that I had saved off to the side. Oops, thanks. Again, typos, stage, always happens. All right, so that's going to start off and running. And it needs to be warmed up again because I only ran it an hour ago, and I have it set to turn off these things, this production model, if I'm not using it very often to save a little bit of money. But what it's doing right now is actually taking that TensorFlow record input and actually producing, it's running it against the prediction API there that I've decided upon and giving me an actual physical output. And of course, nothing works when you run it on stage. There it goes. OK. So I'm not going to tell you what all this means. But basically, because of the way I structured the input data into TensorFlow records using this approach, it gives me a set of scores and output classes for a given user for a number of different movies. So that's a little bit of that end-to-end workflow. Can we switch back to the slides? So I want to plug a couple things really quickly here, because I didn't do all this work on my own. There's just not enough time to come up with this entire workflow end to end. So I definitely leaned heavily on some of the Cloud ML samples from the Cloud ML team. So they were nice enough to have a bunch of samples, specifically around this data set that I chose, which was really handy. But I urge you to check out that repo, because nothing beats actual end-to-end kind of workflow. And you can read the docs only so often before you actually need physical steps to try out. So these folks have put together something really useful that I would definitely take a look at. And then the other thing I leaned on was a paper that one of my colleagues wrote, Building Recommendation Systems in TensorFlow. And he actually goes through a similar approach where he uses Movie Lens dataset, but he also goes all the way to the end where he talks about things like how to actually serve the model using cloud endpoints, so you have a little bit more API management on top of it, where you get more logging, authorization, and monitoring. But also talking about using Cloud Composer and how you actually update models over time and how you update this entire workflow, right? Today, for the purposes of this approach, I was the one kind of orchestrating the data landing in GCS, cleanse with Dataprep, querying in BigQuery, and all the way to training and deploying the model. But in reality, you're not going to have a person doing that beyond the first couple of times. And that's where Composer is really your friend. And it can help you define that entire workflow and let you run that on a regular basis, right? Again, as you get new data in, you might want to retrain those models or deploy them in a different fashion. So what does the kind of typical workflow look like inside of Google Cloud? And this is sort of a superset of what I've covered here today. But it really does go through the steps of, right, we have all the tools you need to go through from data to ingest, all the exploration capabilities, preparing it, wrangling that data, maybe doing some level of pre-processing, And then getting into the machine learning components, right? Training, hypertuning, testing, and then deploying those models either in online predictions or in batch predictions. And under the bottom there, right, this whole thing can be run by Cloud Composer. Right? It's that orchestration layer. All right. So that's the bulk of what I wanted to cover. Now, where do you go from here? A couple of things to think about as you're looking into how do you adopt these sorts of workflows. So for training, I definitely recommend you take a look at GPUs and maybe even TPUs to boost your training approaches, because just using bare CPUs, you can throw a lot of cores at the problem, but it's not always the fastest way to go, right? GPUs and TPUs are really purpose-built for linear algebra in the former case, and specifically TensorFlow in the latter, so that can have a really significant impact on your training timing. I like using batch predictions to fill in historical data, right? You're not going to need to fill in every single request online, so if you want to fill in some of the prior work, you can do that with batch, and that puts a little bit less strain on relying on another API to fill data in when maybe customers are browsing through your site looking for recommendations. For machine learning, what's great too is, and just this week we have talked more about using scikit-learn and XGBoost. So you don't necessarily have to use TensorFlow if you don't want to, right? There are other ways you can get Cloud ML Engine to host and serve your models and do that prediction for you. And then the last one we talked about a little bit as well was automating the end-to-end workflow with Composer. There's actually one other thing I didn't get a chance to put on here, which is BQML. Right? It's a really powerful tool. Again, inside of that same interface where you can query with standard SQL, we've added some extensions to actually do machine learning right then and there. So you could do things like linear regression right in line. And it's really powerful. Again, that might not be the model used in production, but every little bit of work you do along the way to reduce the amount the next person has to do, that has an impact on how long it takes to get to market. So what about if you want to learn more? So I definitely urge you to check out all of the analytics and machine learning products that we have inside of GCP. It's an incredibly powerful portfolio, and it just continues to grow regularly, especially if you start digging into where we're investing around machine learning, right? We started, I think, with the pre-trained APIs like vision, natural language, and translation. And then we went all the way to the other extreme and said, we'll run your TensorFlow models for you at scale. And now you're seeing us invest a lot more in just the middle, right? What if you don't want to write TensorFlow, but you want a custom model? And that's what AutoML does for us. So there's a lot of work really happening there. And then I would definitely have you check out DA303 later today, a modern data pipeline in action. Again, it takes this work that I'm talking about and gives you a real-world example from one of our customers. As I mentioned, check out BigQuery ML, really cool. I think it's a great tool. And definitely take advantage of the free trial, right? You can do things like store 10 gigs of data for free inside of BigQuery, and your first terabyte of processing or query processing is free every month. So there's a lot of wiggle room there to start playing around with these tools and take advantage of them.